Hi, today I want to explain about FFT. So what is FFT? FFT is a fast Fourier transform. For this assignment, I use FFT overlap method. Uh, why I use this method? Because in this method, the size of the input data block is n equal to L plus m minus 1. That is a general equation, but here I um, change the general equation L equal to m minus m plus 1. So because why I change L equal to m minus 1 m plus 1, because each data block consists of the last m minus 1. The data point of the previous block followed by L. L is a new data point from data sequence of length n equal to uh, L plus m minus 1. So by appearing L minus 1, 0 and points of the FTN sequence is computes once and the star. That's a function of the this equation by following the coding here, here and here. So why I use hash and hash 1? Because in this coding I have to reduce too wide range of noise. So we see the how I define the range of noise. So this original the spectrum of original sound. I can detect the noise from this yellow color of the range. So we can see here the range of the first range of noise is estimate range is 2000 hertz until to 2600 hertz, and the second range is 2800 hertz until 4100 hertz. So here we know the range of uh, noise. So we substitute here the value 195, 241, 334, 399 is from the we calculate actually. So the formula is delta F equal to K over N. So delta F we already know from Fs divided by N. So we know Fs is equal to 11025, and we know N is equal to 1024. So we divide, we get the delta F is equal to 10.77, right? So we know to substitute here, I name is 195 is K1, 241 is K2, for 334 is K3, 399 is K4. K1 equal to the N divided by delta F. The value of N we can get from the original spectrum, right? So here, for N1 is 2100 Hz, and N2 is 2600 Hz, and N3 is 3800 Hz, and N4 is 4100 Hz. So we substitute the N1, N2, N3, N4 in the equation equal K1 equal to N1 divided delta F, K2 equal to N2 divided by delta F, K3 is N3 divided by delta F, K4 equal to N4 divided by delta F. So when we divide, we get value 195, 241, and 334, 399. So here, okay, the function is here is to appear extra zero to tail to generate the last block is always n, which is n equal to 1024. The function is coding is here. Otherwise, for the last block, you y out will be executed 0. If we substitute other and n equal to 1024, the coding we execute error. So the function, actually the main function here is a debugging filter. So to filter the noise and to get the audio without noise, right? So we can see here the difference original spectrogram with after filter. So here the original, so here after filter. We use overlap method is Because why? We need to filter first filter for first noise, second filter for the second noise. That's all. So let me hear the audio after filter, right? So we conclude after FFT, fast Fourier transform, we use overlap method. So no more noise after through first filter and second filter. That's all. Okay, for the second method, I use FIR. FIR is a finite impulse response. So I use Blackman window for this method for FIR. So we can see here our coding. So what is FC1, what is FC2, and here is coding for the debugging the coding, and before is for uh, to using the filter in the coding. So what is FC1 to the second Blackman filter coding? What is FC2 in second Blackman coding? So now we can. I want to explain how we to generate the how we know the noise in the FIR. So let me run first. So how we know the FC1 FC2 for the first Blackman filter coding, and how we know FC1, FC2 for the second Blackman filter coding. So that's FC1, FC2 is the range of noise. We call this is wide range. For the wide range one is 2000 until 2000, 2000 hertz until 2600 hertz, and for the second wide range is 3800 hertz until 4100 hertz. So we substitute the range in here. So for the for the first range, I said earlier is 2000 and 2000 hertz until 2500. So we substitute the value for the range of the noise in the coding. So here is for the formula to calculate FC1 over FS over to FC1 over Fn we calculate before. So that this is for the function for the debugging. So this to figure out the output, which is like this. So FC1 and FC2 for the second filter, and for second noise deep wide range is 3 3800 hertz until for 4300 hertz until here. So as I mentioned earlier, Fn equal to Fs over 2, while Wp equal to Fc1 over Fn we calculate earlier. So here the function is for the debugging. So yeah, so this all for the filter. So this audio write to save our new audio after the filter. So this is original, spectrum. So let me see the after filter. So here the spectrum band stop after filter. So here the yellow is at the noise, and the blue one is the after filter the noise. So in this no more noise actually. So but let's we see the output, the audio. So I play the original audio first. Okay, this is the original audio actually. So let's play the. This is FR. As you can hear, no more noise, but actually have a little bit noise because the I know because here not the exactly range of noise, because I just estimate, right? So when we know the estimate range, we can get clearly output. So actually I forgot to explain what is N. This is the stage of the filter. So I use the 201 for this stage. That's all from me. Thank you.